This is the Ellipse airship out in our parking lot. It's a test bed for a lot of the technologies that we end up putting in our much larger airships. The Ellipse is 30 feet long and shaped like a V. We build this little airship, tear it apart, and build it again, over and over. We try new structures, new ways of mounting equipment, and new internal configurations. We find answers on the little ones before we try them out on the big ones. This is what it looks like on the inside. This is from the nose looking down the arms. These tubes are air beams. It's the latest modification to the Ellipse. The air beams are the structural component of the airship. They are held apart with foam spacers. This gives the cross-section of the airship its elliptical shape. They are not like tubes of a raft. Air beams have a flexible inner shell and a non-stretchable outer nylon shell. The combination makes for a very rigid structure when pressurized. Getting the air beams right and figuring out the best way to mount them is the main focus of the Ellipse. This carbon fiber truss is 100 feet long and weighs less than 20 pounds. We have used carbon trusses in all of the 9 airships we've built so far. But we need to be lighter still. It's a scaling issue. The air beams in the Ellipse are actually heavier than the original carbon trusses. However, at over 200 feet, air beams are actually lighter than the carbon trusses. We are planning airships 6,000 feet long. Air beams are the way to go. The Ellipse itself has already flown twice in its cylindrical cross-section configuration using carbon fiber trusses. We want the airship to pack down for transport to the launch site. We're now fine-tuning the air beam mounts so they don't shift location during the move. We will still need to mount the foam spacers and the helium lifting cells at the launch site, but we don't want to mess with the air beams. It's just too time-consuming for the morning launch. It's very surreal working inside these blue tubes. The big airships make you feel like you're stepping into another world. We need to start early in the morning or work at night. The temperature inside exceeds 100 degrees even on cool days. But hangars are expensive. The one for the Ascender 9 was $20,000 a month. So it's mornings in the parking lot and lots of bottles of water. The spacers are in place. The airship is only half inflated here. That's why the bottom looks flat. If we inflated it all the way, the team would have a hard time moving around. This is one of the 4 helium lifting cells that go in the arms. The next launch of the Ellipse will look like this. This is the slightly larger airship, the Ascender 36, taking off. The Ascender 36 had a cylindrical cross-section and used a carbon fiber truss for the internal structure. We've modified our launch site specifically for the Ellipse. We have 2 shipping containers 50 feet apart, capped with a 12-foot high fence that we cover with wind fabric. We're going to launch and let it climb 200 feet and then bring it down on tether. We're going to do this over and over again and pretty much push it and stress it until we break it. After flight, there are 3 big modifications we'll be testing using the Ellipse. First, we're going to put a rocket engine on it. We're going to mount one of our small plasma engines. It's too small to actually push the airship, but it will teach us how to integrate the engine into the system. Then we're going to sew solar panels on it. Even with the lightweight thin film solar panels, the Ellipse will be too heavy to fly, but it will allow us to experiment with all the different attachment methods. Active drag reduction. We need to get this tech out of the lab and into the real world. The Ellipse does that. It works in the smooth lab environment. Now we need to shake out all the problems with choppy real-world airflow around a flexible surface. The Ellipse is just a little guy, but it is the gateway to the technology and a builder of the experience we need for the giant airships to come. The systems we install in the Ellipse directly apply to both the Ascender load airship and the orbital H-1 airship. The Ellipse airship may not look like much, all battered and worn as it is, but it has a place in our hearts. telling us exactly how we messed up and got it wrong, and even when we've got it right. I have a feeling that even after the next 30-meter Ascender 11 and the 100-meter piloted Ascender 12, we'll still be dragging the Ellipse out into the parking lot to figure things out. Join the team. Check out our Patreon site. There's a link in the description. JP Aerospace, America's other space program.